All right, percent composition in popcorn. This is a virtual lab activity. So you already completed a paper pre-lab. The pre-lab was returned to you and you were given a lab handout. All right, this was returned to you. The number of minutes you earned was recorded here, okay? In this lab, we're going to apply some of those skills, mostly the percent composition, and we're going to practice. So when you got the pre-lab back, you should have also been given this lab handout. And so take a moment and make sure that you have the top filled out. You're going to follow the directions and complete this lab activity, the calculations, the analysis, and the problems with your lab partner or partners. So use the resources in the lab folder if needed. This lab is going to be worth 100 minutes total. You have to show work for problems and calculations. Again, if you're absent, sleeping, not participating on your phone, you're not earning lab minutes. Okay. If you complete this lab as a play posit, you will earn virtual lab minutes, but remember you must score an 85% or higher in order to earn those virtual minutes. Okay, as a reminder, we're going to be looking at popcorn in this lab. And so we think about this pie chart as a representation of everything that is present in a popcorn kernel. Okay, we have one of those pieces is water, H2O. Okay. We have some carbohydrates, okay? We have other things present in the popcorn, but one of those pieces is water. And that is present in all of these popcorn kernels. And when the popcorn pops and looks like this, some of this water escapes. Okay. How do we know? When you open up a bag of popcorn, after you pop it, you will see steam escaping. Okay, and that is the water. Where did it come from? It came from those popcorn kernels themselves. Now you may say, well, maybe it's the oil. Well, in the experiment we're doing today, we are just adding popcorn, no oil, no salt, no anything else. So whatever you see, whatever change you see, you know that it was a change just in the popcorn itself. Okay. So as a reminder, part of popcorn is water. When we heat popcorn, it pops, and then the water is released as steam. So after popping, the mass of the popcorn should be less. So if I measured 5 popcorn kernels before and 5 popped kernels after, the popped kernels should have a lower mass. Now that mass did not disappear, remember, it was just converted to steam that escaped, okay, as the popcorn popped. All right, so the directions for lab, you're going to use a Lysol wipe and wipe down your table. You need to get your materials. So what do you need? You need a small paper bag, it's little, 1 electronic balance, and 1 container of popcorn seeds. It's about 25 seeds. The number isn't super important because we're going to rely on mass and not counting, but just in case you were wondering. As you work through the lab, you're going to be filling out the data table at the top. So there are 4 measurements you need to be recording. All right, let's do the first one. We're going to measure the mass of the empty paper bag. You're going to record it in the data table. If you are doing this for the virtual lab, the data you need is on the next slide. Okay, so look at the measurement on the balance and you are going to record your number right here. Okay, in case it's hard to see, that is where the decimal point is. All right, open the paper bag, open the container of popcorn seeds, and pour all of the popcorn seeds into the paper bag. Notice nothing else, no oil, no salt, just taking popcorn seeds and dumping them into the paper bag. Now measure the mass of the popcorn seeds and the paper bag and record that in the data table. If you are doing the virtual lab, the data you need is on the next slide. Okay, so this one is going to be recorded here. And again, in case it's a little bit unclear, the decimal point in this mass measurement is right there. Now, fold the top of the paper bag over a small amount, okay, about a centimeter. Okay, now I'm not going to come over and measure it, but you can see it's a small fold. Fold it over one small fold, and then fold it over a second time, okay? Then take the bag and you're going to place it into the microwave. Now, I like to put it at the edge of the plate because then as it turns around, it is actually moving around the microwave, as opposed to if you place it in the middle, all it's doing is just spinning, but that's up to you. Close the microwave door and set the timer for 1 minute. So in this microwave, you can just simply press the 1 button and that starts it for a minute. Let the popcorn pop for the full minute, okay? Remove the bag from the microwave. Be careful, it's going to be hot, okay? Bring the bag over to your lab table. Open the bag completely to make sure you allow any gases to escape. Remember, we expected some steam to be released as those kernels pop. So you want to wait about a minute maybe to allow any steam to escape from the bag. Also for it to just cool down a little bit. Now we're going to measure the mass of the paper bag with the popped popcorn and record that in the data table. If you are doing the virtual lab, the data you need is on the next slide. Okay, so right here, and again, just because it's a little bit hard to see, right here is the decimal point in that mass measurement. All right, so now what we're going to do is get a paper towel and pour all the popcorn onto the paper towel, because we know that not all of the popcorn kernels pop. And what we're going to do is find any of the unpopped popcorn seeds and put those back into the paper bag. Now, if the seeds are cracked or open or partially popped, we're not going to include those. We're only looking for the ones that really don't look like they've popped at all, because we're trying to find the ones where steam or water escaped from, right? So if there's a crack in the seed, easily water could have escaped. So we're just looking for the ones that remained unpopped. Put those back into the bag. Now you're going to measure the mass of the paper bag and the unpopped popcorn seeds and record that in the data table. Now the data for the virtual lab is on the next slide. All right, so here we are. This is the measurement. This one you can kind of see a little bit better, but I'm just going to darken that decimal point just in case. And you're going to record this data. All right, so now at this point, this data table should be completely filled out, okay? We have 4 measurements. Now it's time to do some calculations. Now, if you are doing this lab in class, make sure that you follow the directions to finish the cleanup, okay? But since we're focusing on the virtual lab here, we're going to go through calculations. So here are the measurements we have. So let's think about them for a moment. This was just the bag, right? This was the bag with the popcorn before we put it in the microwave. This is the bag with all of the popcorn, again, after we took it out of the microwave. And then this is the bag plus the unpopped seeds, okay? Now there's a lot of variation in those numbers, right? You can see, first of all, this was before I put it in the microwave. This is when I took it out. You can see that mass changed, right? So a reminder, the law of conservation of mass states that mass must be conserved. It cannot be created, and in this case, it for sure cannot be destroyed. The mass that was lost was not actually lost. It was the mass that was just converted to steam, and it escaped as a gas and just floated away when we opened up the bag, okay? All right, so now we're going to use this data. So this is the data from the virtual lab, okay? And this data is what I'm going to provide an example of here, okay? Now, those of you completing the virtual lab, you're going to use these numbers, and I'm not going to put the correct answers up here right away. Those of you who are doing this in class, use the numbers you have, but this just kind of shows you a model of how to do it. So first it says the mass of all popcorn before heating. So all of these measurements up here include a bag. So I don't want the bag, I just want the mass of all the popcorn before heating. So this is the mass of the empty bag, and this is the mass of the bag with the popcorn before heating. So what I'm going to do math-wise is take the mass of both of them before minus the mass of the empty bag, okay? And that's going to give me a number here, right? What about the mass of all the popcorn after heating? Okay, well, the mass of all of the popcorn after heating was 6.00, but that's with the bag. I need to get rid of the bag from that measurement. So that's 2.40, right? And that is going to give me the mass of all just the popcorn without the bag in there after heating. Now, this last part is just important for our calculations. Remember, some of those popcorn kernels did not pop, meaning I don't have any change in mass for those popcorn kernels. So what amount did not pop? Okay, well, this right here is the mass of the bag with the unpopped kernels. And this is the mass of the bag. So to find the mass of the unpopped kernels themselves, I need to take this measurement and subtract away the bag, okay? And then that is going to give me a number here, okay? So that's the mass of the popcorn kernels that did not pop, okay? So now why am I doing that? Well, here we go, adjusted mass. So it says here, now use the value in C to find the adjusted mass of the popcorn before and after heating. So here we had the mass of the popcorn before heating, right? Whatever number you had here. But some of that popcorn did not pop, so we have a number here. So this is too big of a number because some of it didn't pop. How much? This much. So what I need to do is take all of the popcorn, that's A, right? But minus C, I need to subtract away the popcorn kernels that did not pop, their mass, okay? And similarly, to find the adjusted mass of popcorn after heating, I have a number here, right? But it's too big. Why is it too big? Some of those popcorn kernels didn't pop. This many didn't. Okay, so then I'm going to take B minus C. Okay, and that's going to give me that adjusted mass of popcorn after heating. Okay. So now how do I find the mass of the water present? Well, this is the mass before heating. This is the mass after heating. This one right here should be smaller. It's less, okay? And how much less? Well, that is the water part. So what I'm going to do is take the bigger number before heating minus the number after heating. And whatever that difference is, that is what was released as steam, okay? Now, to find the percent mass of water in the popcorn. So I'm just going to write it like this. You do percent is part, right, over whole times 100. I can't tell you how many times people forget to do the times 100 part, and it makes me, don't do it. All right. So I am finding the percent mass of water. Okay, so the part is the water. So this is the part. So that goes into that part of the formula. And then what is the whole thing? It's the popcorn, right? Would I use the popcorn before heating or the popcorn after heating? That's what you need to decide. Think about, when was the water part of it? Was the water part of it before or after we heated it? So it's going to be one of these two numbers. You need to decide which one, and then that goes in the spot for whole, and you divide this number, the part, times the whole, and then you times it by 100. Give your answer to 2 digits after the decimal, okay? Now, percent error. We're going to assume that popcorn contains 10% by mass of water, okay? So that is going to be our accepted value. It contains 10%. The measured value is always what's done in an experiment in a lab, and that is what you just calculated right here, okay? What I need you to make sure when you do measured value minus accepted value, either you've put that in parentheses or you've pressed equals before you continue, and then divide it by the accepted value and multiply by 100. Now you have a lab analysis question to answer. What sources of error may have affected your results? Where might there have been mistakes? Okay. Think about when you actually did the experiment, and then also in the calculations. Where might you have made mistakes? Or where might you have not done things exactly as you were supposed to? So what may have affected our numbers? All right, then you're going to complete the analysis problems. If you are struggling here, go back to the pre-lab video, because I'm not going to walk you through more here. This is the same thing. These are just problems with an increased level of difficulty a little bit. Okay, so there's still going to be gram formula mass, moles, grams, percent composition, greatest, but I think this time it's least percent by mass. And the only thing that's added in here is you're going to do some percent error calculations as a reminder of what you just did in lab. Now you're going to turn in the lab handout to me, and it is going to be checked for minutes, and then it will be returned to you. But you should be completely finished at this point.